Hello everyone, welcome to Finite Element Support Abaqus YouTube channel. Today we'll see about cantilever beam bending with vibration. So cantilever beam, which that's simply supported beam at one end, and there is a concentrated force on the other end. Then you apply a force of 1 Newton, a simple force, and in one end there is a incaster. Then I apply force, it will be bent. So whenever remove this existing load, it will back to play what vibration or natural frequency there. So we'll see how this displacement in versus time without damping, and when you have added damping factor, what the variation this displacement plot. You will see a step-by-step procedure. So let's start as a 2D model. Go to new, create a part, say beam, then say make it 2D and deformable, like wire, then put 0.5 as approximate size, then create a line, put a coordinate 0, 0, 0.1, comma 0, which is 10 centimeter length exist. Then go to property and add a metal property, name as metal or any name you can give it. Then general, add density 2600 is. Then go to mechanical and elasticity, elastic, then Young's modulus value 5.6 the power of 8, and Poisson's ratio 0.3 makes this the metal property. Then go to here section, make it like a beam section. Select beam and type is beam as a default, and continue. Then profile, it is a rectangular profile, so go here, click this icon, then select this rectangular profile, then add this width and height of the rectangle. So it's similar like a square value 0.005, 0.005 is rectangular cross section. Then profile names as a profiles, then as it is material name is call it metal, click OK, then assign this metal, so as it is beam section. Okay, then go here material orientation, because we are doing on beam bending, so it must be apply here this material orientation. So as a default 0, 0, -1 is just accept it, then go to assembly, then create instance, make it independent. Okay, then create step module. On step module, create step so as it is static general, the first step, so as it is time period is 1. Click OK. Okay, let's rename this step loading, because later on will unload or remove this load. In order to see the vibration, we'll remove this loading. So the first step we have is loading. Then go to here, field output request. You can edit this one, remove this strains, force and contact. So only we have this stress and displacement. Can choose all. Then later on we'll find the appropriate parameter. Click OK. Then go to load and create load, concentrated load. That is, you can say force, concentrated force. Okay, then select this end point. Okay, then in y direction, that is a downward force -1 in Newton. That means magnitude is 1 Newton downward force is here. Apply OK. Then go to boundary conditions. As it is, make it initial step mechanical, and symmetry and symmetry in caster. Then continue. Select this first point, then make it in caster, concentrated in all direction. So finally go to mesh module, then select this, make it by number and choose like 20, divide into 20 equal parts. Apply OK. Then mesh it. So you must find, or you must check the material type here on mesh type. Here in assign element type, then select the geometry, then beam standard. So you can choose this hybrid formulation, then click OK. Then create job module. You can say beam bending, continue. Click submit the analysis. Click OK, and then wait. It requires a very short time, complete within 1 minute. Okay, the results come out. Then go to results, then see the bending. So if you want to a clear visualization, go to here, ODB display option, then extrude. In this general tabs, just render beam profile, apply. Then you can see the object in a real physical way. Go then apply this. Can reduce this frame rate, apply. So this one is the first step. Let's go to other this vibration step. To do this, let's go to here and copy this model. Copy and go to here and create other step, that is unloading step. So here is loading, the force is applied at one end, but after loading we suddenly remove this existing load, so this material will move up and down, that is vibration is there. Then create unloading. Unloading step and that's dynamic implicit model. Continue. Then let's for 2 seconds. Then incrementation, go to here. Then make it fixed and let's make it 300 frame. Increment size let's reduce to 0.01. So in other tab you can use all the default parameters, but you can specify this alpha, that is damping control factor. If you specify like minus 0.1 something like that, you can add. Let's see as a default without any damping how the vibration looks like. We'll see this. Okay, click OK. Then we create a job. Create job, that is bending frequency, you can say. Let's vibration, continue. Okay. Before that, what we'll do is the other thing, go to this load module. So in load module, go to here, load manager, and here it says as propagated. The load is propagated from step 1, so make it is deactivate, because in step 2 we will remove load. So deactivate this one, then go to back to this job, then submit this. Okay, before that, let's go back to this step module. We miss one thing in history output. They create in second step, that is a loading step. Then on set, we set 1, select set 1, then see displacement rotation, then choose this translation and rotation. Then this every n increments, let's reduce this one to 1. Okay, then go back to job, then resubmit this analysis. Okay, the job is completed. So go to result, then see, choose this deformed shape, then on XY data just right click and create XY data, that's ODP history output. They click continue, and unit displacement versus time, how the oscillations looks like through time. So go to this partial displacement U2 plot. So this the vibration is looks like this one. So if you add damping, how this oscillation is reduced. So if you add the damping factor, it will this oscillation will shorten for some time. So this way you can calculate the vibration and like